H53 analysis brings light into the darkness of hydrocarbons in the environment. Find out in this FlashTalk how this can be done safely and sustainably. The automation of this method using the GERSTEL MultiPurpose Sampler was developed by the RIC group. Hydrocarbons and water are a hot topic for the environment. The H53 method is a method for determining the hydrocarbon index according to DIN and ISO 93772. The method is suitable for hydrocarbons with a chain length beginning from C10. The analysis is then done by a gas chromatography system coupled with an FID. The hydrocarbon index is determined in different matrices, like surface water or drinking water, or sewage water or sewage treatment plant drains. Once we have our water sample in our vial, the manual sample preparation workflow looks like this. From sample to the data evaluation, we have to go to several steps like liquid extraction or concentration and cleaning. For the manual workflow, we use a lot of hexane, about 2 liters. And the preparation of 12 samples needs 7 hours and costs about $98. Is there an alternative? Yes, there is the automation using the GERSTEL MultiPurpose Sampler. And in the following, we will show you how the automated workflow looks like. We are starting, as always, with a sample, and then open the vial with our decapper-recapper system to avoid piercing the scepter. Then the liquid-liquid extraction part begins, adding hexane, adding the internal standard, shaking, and then optional centrifuge the extract. After the liquid-liquid extraction, we continue with the cleanup, beginning again with open our vial with the decapper-recapper system, transfer the extract phase, and then shaking and settling. After the extract is settled, the analysis directly begins with the injection of the extract phase into a GC-FID system. And the complete system with GC-FID and the automated sample preparation then looks like this. It's not a classic GC-FID analysis, but a large volume injection. This means that we inject in this analysis about 100 microliter onto a GC column. So it's not only a large volume injection, it's also an on-column injection. To be precise, it's a cool on-column injection, which means that the uncoated pre-column is in the GC oven by cool temperature. Here we inject the 100 microliter sample, and the GC oven temperature is at a temperature where the solvent is evaporating and the analytes remain onto the pre-column. The gaseous solvent is then leaving the system through our early vapor exit. This prevents that the huge amount of solvent enters the analytical column and damages this. After the complete solvent is removed from the system, a valve inside the eave is closed, the GC oven heats up, the analytes go into the gaseous phase and are transferred splitless onto the analytical column. Using this directly coupled automated sample preparation with the analysis system gives us the opportunity to overlap the sample preparation steps with the analysis time, and therefore we can analyze 24 samples within 24 hours. A common chromatogram from the H53 analysis looks like this. The chromatogram doesn't have nice and sharp peaks like in normal GC-FID analysis. We have a huge and broad hump instead. The thumb parameter H53 are determined by integrating the whole hump and the settled peaks. Our partner, the ARC group, evaluates the method by determining repeatability, recovery, the LOD and LOQ, as well as the calibration. For the repeatability, they are looking for 6 different runs, and the RSD by the repeatability was 3%. For the recovery, they used spiked water and determined a recovery of 99.4%. The determined LOD is 8 ppb and the LOQ 30 ppb. For the linearity, they obtained a value of 0.999. Let's compare the manual sample prep with the automated sample prep. As we see before, using the manual procedure, we spent 7 hours and 2 liters of hexane. By automating these sample preparation, we have to spend 12 hours for 12 samples. It's more compared to the manual procedure, but the MPS works 24/7. The main advantage is the amount of hexane is reduced from 2 liters using the manual procedure to 0.012 liters using the automated sample preparation. And therefore, the automated method is greener and safer. Additionally, you have a faster and better extraction using our quick mix. If you want to have more information of our vertical shake quick mix, see our other FlashTalk about our auto twister. We have a simultaneous drying and cleanup with a dispersive fluoroseal cleanup method. Using the optional centrifuge, we have a better and faster separation between the sample and the extract phase, and therefore the transfer of the extract phase is more precise. Last but not least, by using our decapper and recapper system, we are preventing contaminating our extract phase with siloxanes due to avoiding piercing the septa during liquid-liquid extraction and cleanup. Sustainable, efficient, and safe. This is the automated H53 method. Making water analysis work. Watch out also the other videos of our FlashTalk series and stay curious.